All right, so if you're an architect tasked with building the next generation of AI, you've come to the right place. Today, we are laying out the entire blueprint for taking a powerful language model and turning it into a smart, active, problem-solving agent.
Okay, let's dive in. Here's our game plan for today. We're going to start with the AI's core reasoning loop, basically its brain. Then we'll give that brain hands by adding tools. After that, we'll build it an external memory so it can actually learn your specific data. And finally, we'll wrap up with the big architectural choice that every single builder has to make.
All right, first up, the heart of the machine, the AI's reasoning loop. This is the absolute fundamental process that turns a passive model into an active agent that can literally think its way through a problem.
So you have to understand, a standard large language model, no matter how smart it is, has one massive limitation. It's an incredible reasoning engine for sure, but by itself, it's just a brain in a jar. It can think all day long, but it can't actually do anything in the world around it. So that brings us to the core challenge, right? How do we build a system that can go beyond just thinking and actually start solving complex, multi-step problems out in the real world?
Well, the solution is this really elegant and powerful framework called React. And it's exactly what it sounds like, reasoning and action. It gives our AI a super simple, repeatable process. The agent forms a thought about what it should do next, and then it takes an action to get there.
You know, the best way to visualize this loop is to think about a chef cooking some soup. First, the chef thinks, this soup, it needs more salt. That's the reasoning part. Then they act. They add a pinch of salt. And finally, and this is the most critical step, they observe. They taste the soup. That observation feeds right back into their next thought, and the whole cycle starts over again. And that's really the secret sauce here. This constant cycle, observe, reason, act, is what defines an agent. This little control loop is what allows it to iterate, to self-correct, and ultimately to decide, okay, my job here is done.
So our agent has a brain, and it can think in a loop. Awesome. But now we need to give that brain some hands. This next part is all about connecting the agent's mind to the outside world by giving it tools.
We keep coming back to this brain in a jar idea because, as architects, it's the central problem we have to solve. To make that act step in the React loop actually mean something, we have to give the agent a way to, touch and manipulate real external systems. The way we do this is with a capability called tools, which you'll often hear implemented through something called function calling. Just think of these as a set of APIs that you, the architect, give the agent permission to use. It could be anything, really. Looking up customer info in a SQL database, or calling out to an external shipping API.
So let's look at the actual data flow here. It all starts with a thought from the agent, something like, I need the status for order number 12345. The reasoning engine then translates this into a machine-readable action, in this case, an API call. That API then sends back a structured piece of data, the observation, which becomes the critical input for the very next think step in the loop.
Fantastic. Our agent can think and it can act. But its knowledge is still kind of limited to whatever it was trained on. So let's move on and build it a custom library, an external memory, so it can become a true expert in your specific data.
And look, this is probably the single biggest challenge for any enterprise architect out there. How in the world do you make an agent smart about your company's internal documents, your product specs, your private wikis, all that data that's proprietary and changing constantly?
Well, the answer requires a huge shift in thinking, away from old-school keyword search and towards what we call semantic search. See, instead of just matching exact words, semantic search actually understands the intent behind what you're asking. It knows that when someone asks, how did we do financially last year, what they're really looking for is the Annual Revenue Report 2024.
So what's the magic that powers this?
It's a technology called embeddings. The absolute best way to think about this is like we're creating a giant, high-dimensional map of ideas. We translate every piece of text, every concept, into a set of coordinates. And on this map, ideas that are contextually similar, like say, quarterly profits and company earnings, are located right next to each other.
So as an architect, how do you actually build this? You use a three-step pipeline called RAG, which stands for Retrieval Augmented Generation. First, you do chunking, where you break your big documents into smaller, more manageable pieces. Second, you do the indexing, where you convert each of those chunks into a vector embedding, its coordinate on our map, and you store it. And finally, there's retrieval, When a user asks a question, you use that vector search to find the most relevant chunks of information to answer it.
Now, let's be honest, building a RAG pipeline from scratch is complex. It's a ton of work. The great news is that managed cloud platforms can handle all of that heavy lifting for you. Services that are designed for search and conversation can manage that entire pipeline, the chunking, the indexing, the retrieval, so you can just focus on your application's logic. So, with the full conceptual architecture now in place, we've got a reasoning loop, tools for action, and a memory powered by RAG, we finally arrive at the last and maybe most practical question every architect has to answer.
And honestly, this decision is best framed with a simple analogy. Are you trying to build your own car from the ground up, or do you just need to get somewhere fast by hopping in a taxi? It really all comes down to a trade-off between total control versus pure speed and convenience.
This table kind of lays it all out. On one side, you have open source models. Their key benefit is total transparency and control. That's you building your own car. You can inspect everything, modify everything. On the other side, you have proprietary models. They offer speed and ease of use, getting you to your goal way faster with all the latest features. That's your high-performance taxi.
But here's the really important part. This isn't an all-or-nothing choice anymore. A key feature of any modern AI platform is that it embraces an open ecosystem. And what that means for you is that you don't have to choose. You can use a proprietary model for one task, an open source one for another, all in the same environment. You get to pick the right tool for the right job.
So, let's just quickly recap the blueprint we've assembled. First, the loop. Agents run on that think, act, observe cycle. Second, the tools. Function calling gives that agent hands to work with APIs. Third, the memory. The RAG pipeline connects your agent to your proprietary data. And finally, the choice. You get to strategically balance the control of open source with the speed of proprietary models.
This architecture is an incredibly powerful foundation for systems that can reason, act, and learn. So we've given you the blueprint. The only question left is, what will you build?